So today what we want to talk about is what if we're raising a power to a power? How does that look? So that's our objective, is to understand and use the rule when multiplying or when raising a power to a power. So in other words, we're talking about an exponent to an exponent. That's what our conversation is all about. Okay, so something that looks like this. Actually, let me move it over here. So we're going to do just like we've been doing. We're going to give two different types of examples, one with numbers, one with variables, and then see if we can get a pattern from it. All right, so what does 3 squared to the 4th power mean? What does 3 squared to the 4th power mean? Joey?
So you would solve 3 squared, which is 3 times 3, so it's 9. So it's 9 to the 4th power.
Okay, that's good. However, we're going to keep it as 3 squared.
Okay.
So can you tell me if I keep it, instead of making it a 9, if I make it 3 squared still?
Oh, you can make it...
What would I write that 3 squared to the 4th power means?
Like, couldn't you make it 3 to the 6th power?
Okay, hold on. Nope, you got to tell me what it means. You're jumping ahead to what the answer is, but I want to know what this means, because then that way we can verify what the answer would be.
3 squared to the 4th power.
Yeah, what does that mean? What does that tell you to do with 3 squared?
Tells you to multiply it 4 times.
Okay, so tell me what to write. So I've got 3 squared times...
3 squared times 3 squared times 3 squared.
Okay, good. All right. Now, does that look like something we've covered already? Yeah. Remember back in our first set of rules when we were multiplying monomials? And what was the rule when you multiply monomials? What do you do with the exponents and the bases are the same?
Cancel them.
We add them, right? So this was back from Thursday. And let's see, 2 plus 2 plus 2 plus 2 is 8. Oh. Joey said 6. That's interesting. All right, well, let's do another example and see if we can go and figure out what the rule will be for this one. So let's do one with variables. Let's do y to the 5th, and I want to cube it. So, Tori, what does y to the 5th cubed mean? Exactly, right? It just says, hey, this outer exponent says how many times do I multiply the guy inside the parentheses by itself. Okay, and then Sophia, what do we know to do when we're multiplying monomials and the bases are the same? What do we do with the exponents? Okay. And we get y to the 15th. Okay, so look at your original problems. 3 squared to the 4th power equals 3 to the 8th. Y to the 5th cubed equals y to the 15th. Can you see a rule that we could make from this of how we could get the answer without having to draw out the picture? Isabella?
Yes.
You weren't paying attention, were you? Your job is to come up with a rule. What's the rule? I don't know, it's not the rule. That's not going to help me solve. See, you really need to pay attention, otherwise you kind of look silly in class. Okay, Kelly, what do you think?
Multiply the exponents.
Okay, so we have to put in all the other pieces in front of it. So when raising a power to a power, you're going to multiply, and again, I'm going to box that word because that's the key math that goes on, the exponents. So when raising a power to a power, you multiply the exponents. Now, can you see something physically about this problem that might help remind you that you're going to use multiplication with the exponents? So let me go on to the next screen. Excuse me. As soon as I see that everybody's done writing, and then we'll write a problem up again. And see if you can see something that's physically going on just in the problem itself that would say multiplication is the key on this one. Let's see. Hold on. Okay, everybody ready? Yeah? Alex, you got it?
Close.
Okay.
So in our homework, we don't have to write out the whole thing.
If you're struggling with this idea, it has to be an independent thing. You either are going to show me all of these steps, or you're going to have original problem equals answer. It depends on if you get the strategy, the rule, and can apply it. Now here's the trick. You guys are taking a quiz this Friday, and it's going to have all the different problems, and it's not going to tell you which rule to use. That's your job, is to figure out which rule to apply in that situation. And so we have to kind of know it. Okay, so it depends on you what you're going to write down. So if I have, let's see, x squared, and I want to cube it, is there something there that kind of reminds you need to multiply? Okay, Sophia? Yeah, if you think about it, if we've had something like this, when we had something next to parentheses, we've always interpreted that to mean multiplication. So the same idea applies here, but where that idea applies is just to the exponents. Okay? So, and notice on the one before, when we did it with the base of 3, the 3 didn't change. I still ended up with the base of 3. It was only the exponent that changed. Okay? So this kind of reminds me, oh, parentheses, 2 numbers separated by parentheses, that's a multiplication. Okay? All right, so that is going to be one type of problem that you might be seeing. Let's talk about, let's see if there's anything else. Ooh, yeah, let's do a couple of them. Let's talk about what if we have this problem, where I have more than one thing inside the parentheses. Let's do an example of this and then see if we can come up with this. A rule. So, okay, so now I just don't have a base, right? I have a coefficient and a base. Let's see how that affects how I raise to the power. So what does 3x squared cubed mean, Jonah? What would I write?
3 times 3.
No, let's just go back to the beginning like we did here, where we had 3 squared to the 4th power means 3 squared times 3 squared times 3 squared times 3 squared. Do that same thing here. So what does 3x squared, that quantity cubed, mean?
3x squared
Uh-huh.
times 3x squared
Okay.
times 3x squared.
Okay, so let's stop there. Okay. Now, remember dealing with this problem back on Thursday when we were multiplying monomials? There's coefficients and variables with exponents. What did we end up doing with the coefficients? Which, by the way, are these guys. Bam, bam, bam. What did we do with them, Kyler? No. Because the 3 is part of what's inside the parentheses that the exponent 3 is attached to. So we have to treat him like everybody else. So, remember with the coefficients? Oops. We have the 3 times the 3 times the 3. But with the variable, we add. So that was our second part of our rule from Thursday's notes. So what's 3 cubed equal to? So we get a 27. And what's 2 plus 2 plus 2? Okay, that was the easier one. Was 2 plus 2 plus 2. So our answer is 26x to the 6, or 27x to the 6. Okay. Let's try one with a little bit more to it. What if we have negative 5x to the 4th, y to the 5th, z squared, and I want to raise that whole thing to the fourth power. Okay, Cameron, you're not writing stuff down. That's a lot, right? How many times am I going to write negative 5x to the fourth y to the fifth z squared according to this problem? 4 times. Okay, so let me see if I can write it small. I'm going to scooch it down here. So let's see. We are going to have negative 5x to the fourth y to the fifth z squared. Negative 5x to the fourth y to the fifth z squared. I'm not going to make it negative 5x to the fourth y to the fifth is z squared. So I'm going to steal one right here. Negative 5x to the fourth y to the fifth z squared. Oh, dear Lord. Okay. So from that, coefficients, what am I going to multiply? Kina. What are your coefficients?
5.
Oh, careful.
Oh, sorry. 4.
No, careful. Look at your coefficient.
The X.
Nope, he's not a coefficient, he's a variable. What's the coefficient, Kina? Pardon me?
I don't know.
No, I don't know is not an answer. We have it in our notes. I would be looking through my notes in a big hurry so I could answer the question. I think we wrote it down in Friday's notes. May have written it in Thursday's notes too. So what did it say, Kina?
It says when dividing nominals that have coefficients divide or reduce the coefficients.
Okay, we did define what a coefficient was. You're using it within a rule, so maybe look ahead of that or on Thursday's notes, because we did define what a coefficient was.
The negative 5.
Ah, we have to take the entire number in front of the variable. So we've got a negative 5, negative 5, negative 5, negative 5. So we're just going to pull that out and do the math with him. Okay, let's see, Kayla, tell me about the x's. What would I do to figure out that answer?
You could do x4 times x4.
Would I multiply like
No, you
this?
Add.
Okay,
Add the exponents.
so I'm going to add those exponents. Whew. Okay, and then, David, what would I do with the y's?
You add 5 plus 5 plus 5
Oh, yay, and then we've got one more in here. Okay, and let's see, Connor, what would I do with the z's? What am I going to do with the exponents on the z? Okay, and what are the exponents? What are they? And how many of them do I have to add? I have 6 of them? Let's see, 1, 2, 3, looks like 4. Which happens to be the same as that number up there. Okay, so my granddaddy answer, negative times a negative is a positive. Negative times a negative is a positive. So I'm going to get a positive answer. 5 times 5 is 25. 5 times 5 is 25. And through multiple times of doing this math, I know that 25 times 25 is, does anybody know that? 625. Yeah, a lot of things we just memorized because of repeated seeing it. Now, on the x's, I had 4 plus 4 plus 4 plus 4 for a total of 12. On the y's, I had 5 plus 5 plus 5 plus 5 for a total of 20. And on my z's, I had 2 plus 2 plus 2 plus 2 for a total of 8. So that's the answer there. So let's look at these two answers, compare them back to what we started with. And can we come up with a rule when there is a coefficient that's part of the monomial? Okay?
Wait, isn't there 4x for 4 fours?
Yeah, that would make 16. It's not 12.
Oh, you're right. Sorry. Okay, well, back to my question. What's a rule that we can write? When raising powers that contain coefficients to a power. I'll get you started. When raising a power with a coefficient to a power, what do we do? What happened? The 3 from the 3x squared when I cubed it. What did I get? I didn't add 3 times, just like I didn't add -5 4 times. If that was the case, I would have had 9, and I would have had -20. Okay, so that's not what I did. All right, Sophia, what do you see? You multiplied, or you raise the coefficient to the power and multiply it out, then multiply the exponents on like bases. So I got different exponents on my variables because I had different exponents to begin with. And I'm not going to get the same answer when I multiply 4 by 4 and 5 by 4 and 2 by 4. I've got to get different answers because those products are going to be different.
Basically just multiply like the other.
In the coefficients, you end up multiplying it by itself as many times as the exponent tells you. So that's raising it to the power. And then with the exponents, you multiply the exponent by the outer exponent. So there's a lot of multiplication going on that one. So this particular problem may be more one that you need to write out to remind yourself how to get it. Okay? All right. You guys want to do another example? Oh, actually, I do have a couple more. Because we're going to do, yeah. All right, so the same notion applies even if we have a quotient. So if we have a quotient like, let's do this, AB to the 4th, C over C, and I want to cube. By the way, what's the exponent on A? What's the exponent on this A? Giovanni?
1.
Uh-huh. And what about the C? 1. Okay, so if I don't see the exponent, it's always 1. So our rule says, okay, well, if I'm going to raise a power to a power, I'm just going to multiply all the exponents by that outside power. Doesn't matter if I have a fraction or a product. I'm just going to take and multiply all of them by the 3. So everybody gets treated the same. So if we use that rule, we quickly get A cubed, B to the 12th, C cubed. Now, is there any math that I can do to simplify this? Can I reduce an A with a C or a B with a C?
Yeah.
Can I multiply A and B together and get AB to the 12th?
AB to the 4th. The answer, right? Over C.
So what was the key idea that was behind all of our rules, Jacob? What was the key idea behind all of our rules? Okay. But think back to what all of our rules said. What kind of monomials? Where were we doing the math? Could I do, and when we did problems from the past, did we have x's and y's be added together?
No.
Okay. Did we have A's and C's get subtracted from each other?
Could you do like A times B to the fourth over C?
No.
No.
Why not?
It's like
Who
divided
can
by-
who can say why he's not correct in that?
Oh,
Why is he not correct?
it would be A times B because you can't add.
Okay. Kyler's gonna tell you off.
Because you can't add variables here.
Yeah. If the variables aren't the same variable, I can't do math with them. They have to be like bases. That's the key phrase that we used in all of our rules. Connor, sit up. Like bases means they have to be the same base. If they're not the same base, I can't do math with them. So I can't add 3 and 12 together, and I cannot subtract 3 from that number. I can't do that because I have an A, I have a B, and I have a C. So this is as much as I can possibly do. So keep that in mind when you're working on this, that you can do this. Now, I do want to give you one more. What if there's a coefficient? And we kind of talked about this one, too. So let's do, we'll do, I'm trying to find, I don't like any of those. I'm going to make one up, I guess. So I've got 2a squared b divided by 5c cubed, and I want to square the whole thing. Cameron, you need to be actively ready to take notes. So what would we get from in the numerator if I raised 2a squared b to the second power? Caitlin. Keep going. What happens to the a squared when I square it?
A2 plus 2,
Which is?
4.
Okay. And what do I get when I take b and square it?
B.
I just get a b?
Squared.
Okay. Don't say I don't know. Okay, Caitlin, look at your notes. Look at the rule. What does the rule say when there's a coefficient? Read the rule out loud.
When raising a power with a coefficient to a power, raise the coefficient to the power and multiply it out. Then multiply the exponents on like bases.
Okay? So, what am I going to do to the 2?
Raise it to the power
Which is which power?
2.
Okay. What am I going to do to the a squared?
Raise it.
How? What math do we do when we raise a power to a power?
Multiply.
And what am I going to multiply by?
2.
Okay. What about the b? By the way, what's the exponent on the b?
1.
And what am I going to do with it?
Multiply by 2.
There we go. Okay. Now, the one error you made, you said to do 2 plus 2 on the a. And again, when we're raising a power to a power, we're going to multiply the exponents. So we've got 4a to the 4th b, but according to what you've said here, 1 times 2 is 2. So I should have b squared. Okay, Casey, what would I do for the denominator?
For the denominator, you would raise 5 to the second power and c to the second power.
And then how, so show me, or tell me how to write raising c cubed to the second power.
So you would write c, and then you would write c and then 3 times 2 for the
Okay.
exponents.
Okay, and then what would the final answer be
The
then?
final answer would be, for the denominator,
Uh-huh.
would be 10 c.
Ooh, careful.
It'd
What's
be,
5 squared equal to?
5, it's 25.
There we go.
c to the 6th power.
Okay. Now, is there any simplifying that I can do at this point, Cameron?
No.
Okay, why not?
Because
There's no 6 on 25. There's just 25. 6 is on C.
Well, then, yeah, you can simplify it.
How can I simplify it?
Simplify it by 5.
Okay, so if I simplify a denominator by 5, that means I have to simplify the numerator by 5. Does 5 go into 4 evenly? Okay. So, looks like the fraction 4/25 I can't simplify because they don't have any common factors. Okay. Can you simplify the a to the 4th b squared over 6, or c to the 6th power? Why not?
Oh, wait. Yeah. Simplify by 2.
Okay, can I just randomly take out a number from the exponents? Are those like bases? Are they the same base? Is A and B and C the same exact value?
Yeah.
Really? A
No.
is the same as B is the same as C? No, they're completely different things. We have nothing that matches numerator to denominator. There's nothing we can do. Okay, so the answer ends at 4a to the 4th b squared over 25c to the 6th. Okay.